All right, here's another financial math application. This time we've got money, we're putting $100 into an account every month, and we've got a 4% per annum interest rate, and balances up to $15,000. So this gives us a condition on our problem. We would need to check our answer to make sure we're within this value. So one of the parts that I find interesting about this problem is the 4% interest rate. So this is a per annum rate. And what I've always seen is that the monthly interest rate then would be 4% divided by 12. However, what one of the books says, the Oxford book, and also what the way that you would do it in AP math, is to say that the monthly interest rate, after applying the yearly interest rate, we would earn 104%, and that would be over the course of a year, and it would be compounded 12 times. So that would mean our monthly interest rate would get raised to the 12th power because we've compounded it 12 times, and overall we get a 1.04%. So that would imply that the monthly interest rate then is the 12th root of 1.04, or 1.04 to the 1/12. So I hope that the IB would tell you what the monthly interest rate was, because otherwise I don't know what to tell you about which one to use. Hayes and Harris book uses this one. The Oxford book uses this one. So I'm going to show you both ways and hope that the IB takes that into consideration if they give you a problem like this. So if we think about this, if we've put in $100 a month and we earn 4% interest per year, then at the end of our total, if we're thinking about our total amount of money at the end, that first payment of $100 would have received our interest. So if I go with the Oxford way, that would be 1/12, and I would have received the interest 60 times, because once per month for 5 years. And then the next to last payment would have received, our second payment would have received interest 59 times over the course of the year. And then our last payment, so we put it in at the beginning of the month, we get our interest at the end of the month, that would receive it only once. So I've got a geometric series here, and I can find the solution to that using my geometric series formula. I'll leave that up to you. You should end up getting that your total amount of money is about $6,639.57. If we use the Hayes and Harris interest method, then we'd get 100 times 1 plus 0.04 over 12. That's the same as let me just put it all together, 1.003 repeating. And then that would end up getting raised to the 60th power, and so on and so forth. My last one being just that initial, just 1 month of interest. If we work that one out, we would end up with $66,052 approximately. Sorry, not 66,000, 6,652. So the Hayes and Harris way gets you slightly more money. Which way is correct? I'm not sure. Valid points for both of them.